So thanks a lot. Thanks, Arthur, for the introduction, and I'm very happy to be here. So this is a very interesting lineup. This is going to be, again, quite different from the other two presentations that we just saw. So today I'm going to speak about two kind of long-term projects that I'm involved in, and they are both about digitizing the furniture industry. So the projects are a startup that Arthur mentioned called Tylko. Tylko in Polish means only, and it stands for only the designer, the app through which you design, and the factory where you send your design and it gets basically manufactured based on your specification that you created in the app. And the second project is a series called Microlattice. It's a series of free 3D printed chairs that I developed for Joris Laarman lab. So let me start with Tylko. So Tylko comes from the idea that the industries that are tangible, that has to do with manufacturing, are also going to face the digitization process. So digitization already had a huge impact on industries such as photography, such as music, publishing. We all know that there are some new players in the field that basically completely shifted the landscape there, and it is going to happen, and it is slowly happening already. With the industries that are more tangible and have to do with manufacturing. So let me actually, before I go to the video, let me actually quickly try and make a live demo, even though it's a little bit dangerous always. But this is our website. We went live by the end of September. We actually had an official launch here in London at the London Design Festival. So what you can do is you can select a type of product that you would like to customize. And I am going to speak about shelving because this is basically the most complex product from parametric and production point of view. So what you can do is basically you can adjust the product up to 1 centimeter in terms of width. You can choose the number of rows. The depth also changes up to 1 centimeter. And there are also some more aesthetic aspects, let's say, that you can also adjust. So there are 4 patterns here that you can see that you can choose from. For example, this a pattern that is more brick-like, and within the pattern you can still adjust. And here you would be able to see, if we had a slightly higher resolution, that you have available 3 heights of the rows, and also you can choose the type of material. Of course, as you also saw, the price changes automatically here. So let me go back to the presentation now. So we are a multi-platform solution. I actually need to click that. Okay. So the configurators are available on the web, but simultaneously also on the iOS and Android application, and the apps are actually connected with augmented reality, so you can visualize your pieces of furniture in one-to-one scale in your home. So this eliminates the problem of, or at least partially eliminates the problem of buying large pieces via e-commerce platforms, because you can basically test it out with the other objects that you have in your place. And kind of eliminate the issue when buying online. Then, as you saw, the manufacturing data gets sent to the factory, and then the assembly is super simple, and it doesn't require much of the tools. So this is how it works, more or less. So now the question, where we are using grasshopper, and the answer is, as you can imagine, it's pretty much all the way along the process, everywhere. So this is just the outline that I'm going to go through. First is the design process, then of course for all of the data for manufacturing. For shipping, we are also having algorithms that we are developing in Grasshopper that help us pack the parts in an optimal way from the point of view of the shipping company, but also the consumer. I will speak about it a little bit more. And also the assembly instruction is being generated automatically. So first, we have what we call parametric shelving DNAs. So each DNA of the shelf is actually, from the grasshopper point of view, it's not a very complicated algorithm that is behind that, but basically each of the tangible products is described by a set of points. So you saw the points for horizontal elements, then points for vertical elements, and then points for supports. And there's actually some intricate relationship within those, so that we make sure that when our customers interact with any of the parameters, you actually always get a configuration that is good from different points of view. So it's always something that can be manufactured. It's always going to be stable, and of course, very important, it always has to be kind of proportional and aesthetic. So basically, when using our configurators, our customers can never make a mistake. Second important aspect of this approach is that we can basically update our products on daily basis. So even though those are products that are tangible, we pretty much look at them as if they were, as if it was a software, let's say, because you can imagine that we can change the underlying grasshopper script that controls those points, and we can have very different DNAs from the ones that you saw on the website. And if only the manufacturing process is the same, that we can make this update within a matter of days. And this is going to be what we call data-driven approach. So we are actually checking out what configurations and what parameters are being used most heavily by our customers, and our design is basically going to adapt to that and use so over time we'll be able to give them even better solutions to exactly what they are looking for. So moving on to production, of course, when we were approaching manufacturers with this idea and we didn't have yet a proof of concept, it was a little bit difficult to convince them that it's actually going to be feasible to manufacture it. But one of the aspects that makes them convinced is that actually we are batching the orders. So here you can see just a sample batch of 5 shelves. But basically every couple of days we're sending a batch of orders to the manufacturer. So for them, given the scale and the fact that all of the documentation for all of the machines that they are using is being automatically generated on our side, it pretty much doesn't add too much work on their side. Of course, there's additional work that has to do with labeling, but that's pretty much it. So the next aspect is the CNC manufacturing data. Of course, you saw the cutting planes, and now I'm going to show the kind of drilling pattern for the connectors. We are using this sort of connectors which enable assembly without tools that I mentioned already. And so here for a pretty complicated shelf, you can see the automated drilling pattern generated automatically. So we used to send this to our manufacturers, basically in the form of a DXF, but now we are switching to this, which is probably a very natural step to do. So very soon we are only going to be sending G-code, so pretty much they won't even have to be opening the DXF anymore. The packing algorithms, they have to incorporate multiple criteria. So for example, it's very important for the shipping companies that we are using that the package cannot exceed 30 kilograms, and well, our pieces are tangible, made of plywood and solid wood, so they do exceed overall 30 kilograms, so we have to make sure that we have the packaging done right. And also from the customer point of view, we are packing those elements in such a way that they can actually, they don't have to unpack everything when they start, but rather they can just open the first package of the horizontal elements, the first package of the vertical elements, and they, on the top they have the elements that they need to start with. And the last part is the assembly instruction, which is a little bit perhaps inspired by IKEA, but it's also, of course, different for every shelf. and it's also being generated automatically. Yeah. So as I mentioned, we of course the closing image for the ID shelf part. So yeah, we have to remember that those are tangible products made of plywood, made of solid wood, very high quality materials actually. But yeah, but we do treat them as software because basically all of the entire design chain from Parametric from the very beginning, which is how the Parametric DNA up to the assembly instruction is done with the help of Parametric approach. So the second project that I will talk about is a Microlattice series. Very, very different approach from the one that you saw, developed with a team of parametric designers. Basia is actually here, right there, and also Ewa Jankowska, Jacek Markusiewicz, and Ander Gortazal-Balerdi. To talk about Joris a little bit, they are an Amsterdam-based studio. They work a lot with experimental digital fabrication projects. And in 2006, they did this project, which some of you might have seen. It was actually developed in a software that was created for Opel, and it was basically for topology optimization. And they figured out that this can be also used for the design of furniture, basically. So the idea here is to remove the material from where it's not necessary, pretty much, and create an object that is basically a visualization of forces present within its enclosing volume, let's say. Of course, it was changed depending on the loads that you apply and the volume that you start with. So that was the first in the series, and later on that they developed many more other objects that were kind of along the lines of this approach. And in 2013, I believe, actually, they approached me with a brief to create a next iteration of this project. So they wanted to actually make a comment on how it will look like in the future, where you will be able to use 3D printing or other probably next generation 3D printing, which would allow you to create objects that are engineered almost at cellular level. So what we did is somewhat an intermediate step. The cells are still quite big. They're like 1 centimeter large, but it's like an artistic impression of what the future of 3D printing might be. So yeah, the idea was that the chairs are going to be engineered at cellular level. They are going to be responses to the forces present in the base object and also to the functions. And very important from Joris' point of view is that they have to be, of course, beautiful and elegant. So we did a number of structural analysis tests at the very beginning, but I'm sorry to say that too, but we actually departed a little bit from the analysis results in some of the aspects of the designs and how cells are enclosed and opening in favor of the beauty, let's say. So that was at the end the ultimate goal, but of course the analysis was the base for that. So that was actually the very first model that was created for this project. It was, we basically had the first meeting in Amsterdam. We sat down for 2 or 3 hours, and then for the rest of the day I sat down and created this approach, which is of course very, very basic, but it gives an impression of what the ideas were. So we had different types of cells, the cells for seating, cells that are going to be flexible depending on their geometries, and the ones that are going to be structural, and each of those is going to be responsive also to the forces present in the entire object, so they would enclose and open depending on the forces diagram. So those are some of the next, but still very, very early sketches developed for for this project, and for me it was super interesting in the process was that it was a constant feedback loop between the parametric part and the design part, basically. So whenever Joris would make a sketch, I would go and basically try to create a three-dimensional model based on this. The three-dimensional model would of course be a little bit different than what Joris was after, so he would use the three-dimensional model, create like sketches based on this 3D, 2D, very different approaches, and then it was basically a constant back and forth between the two, which turned out to be quite an interesting process from my point of view. And so this is the first chair, 3D printed directly in aluminium. The cell here is a rather not super complicated one in terms of geometry, because it's basically a cube that is filled with a cross, and the cross is being basically closing and opening depending on the forces and also on the function. So the seat surface, for example, has enclosed cells. It was all printed in parts because we were after a high resolution print, and back at the time the metal printing was not yet available for such a scale, but I do hope that it will be available very soon, I think. So this is how it looked like when it was divided into parts, and this is actually the first version that was fully assembled, and you can still see that, for example, in the legs close to the seat surface, on the top of the legs, you can still see some of the connections that later on in the next versions we managed to kind of hide a little bit more. And also, I hope that you can see the kind of diagram of the forces with the arc at the bottom being kind of more enclosed, etc. And the back view. So the second chair in the series used a little bit more complicated geometry of cells. We tested different ones and finally went for the bottom one here. And this one is actually printed in thermoplastic polyurethane, so you can get, depending on the thickness of the wall that you print, you can get something that is elastic or something that is fully solid. So the idea was to have on the seat surface and on the backrest something that is basically fully elastic, so you would feel that you are sitting on a comfortable kind of upholstered chair, but simultaneously from the same material the cells would be more and more enclosed at the bottom, and it would provide rigidity. So this is why we actually did the test of air pressure simulation. Actually that one not in Rhino, I'm sorry. And this is how the chair looked like at the end. It was also at the end basically just colored black, dyed black. And yeah, you can kind of see at the front the V shape, and in the back the X shape that is a resemblance of the diagram of the forces, slightly tweaked for the beauty, let's say. The printing and assembly process again in parts. And here on the rendering, I guess you can see a little bit better the kind of diagram of forces that was mentioned earlier, and also a last series of pictures for this one. And the last one. So this one actually came from the idea of having a single cell that would go through the entire length of the chair, and gradually it would morph through different geometries to basically encompass different functions, let's say. So the idea was that we're going to start with a solid trunk at the bottom, then we're going to move into geometry that is a little bit more like springs, and we would have an elastic layer there, and there at the top we would have a high resolution seat surface layer with tiny cells that would provide comfort. So you would sit on something that is solid, but then the spring part would provide elasticity in a slightly different way than earlier, more because of the geometry rather than the material approach, let's say. So those are some of the sketches from early and a little bit later on. For example, the one that you can see on your right is the one made by Joris. It's just photoshopped. It's not a 3D, but it's an assembly of all of the different models that we did up until that moment. And of course, from there we went even further. And finally, yeah, this is the chair before coating with copper. So it was printed in a polyamide SLS print, and later on, coated with copper. Joris did mention at the first meeting that we had that he wanted at least one of the chairs to look a little bit like a cathedral. So hence this image was created, shot from underneath of the chair, and this is the final look of it. So that's pretty much it that I wanted to share. If you'd like to learn about any of those, please visit those two websites, and if you have any questions. Thanks.
I want to add another layer of complexity. I live in an old home which doesn't have straight walls. Do you see any chance to make your shelves fit? It's under the roof, and the walls themselves are bent a little bit.
Well, okay. Sure. Actually, yeah, what we have to take into consideration when we are creating the interfaces is that we cannot give too much choice to our customers, because usually most of the customers don't have such complicated situation. So most of them are satisfied with the amount of parameters that are already available on the website, but we do have shelves that we call custom, and those are the ones which are done outside of the configurator space. So sometimes we do have calls with requests, for example, for sizes that are bigger than what you can do in the configurator, and we do them as well, but it requires a little bit of additional work, and then it's, I must admit, not like super fully automated then, but yeah, but it's possible to make.
I was just wondering on the process. We saw yesterday two very different techniques to interact through the web with grasshopper system. Do you pre-calculate all the possible iteration, or do you interact more with a live system?
Mm-hmm. Well, what we have is basically we have a script in Grasshopper that only describes those points that I showed. And this is then automatically parsed either to WebGL for the web or to Unity for the apps. So basically that's it. And then the geometry itself is applied in WebGL or in the apps, but it's rather simple because it's just an extrusion of elements. So, but of course, then in those engines we also are adding shading, etc.
Very clever, the interactive shelf design, the mass production, mass customization is brilliant. Have you not been tempted to veer into what the laminates, you know, if you could kind of have the laminates bespokely printed as well, so you get real, or even this clever pixel wallpaper or something, you know, have you thought about the surface? Because everything else looks very clever, but I just think 3 colours, presumably you could really grow that, couldn't you, I guess?
Mm-hmm. Yeah, that's definitely the plan. And for example, right now we are also experimenting with MDF, also for the pricing reason, because we are using pretty much one of the most expensive board materials that you can get. It's a Finnish plywood and solid wood, actually from Poland, but also not very cheap. So definitely MDF is there on the pipeline, and I guess it would be possible. One of the biggest challenges would be again user interface, how to actually make it in such a way that the user doesn't get lost and they don't experience the paradox of choice, where they are basically overwhelmed by the amount of choice that is available to them.
Mitch.
Hi, again on the Ivy shelf, given the flexibility of your manufacturing process and the fact that you're generating G-code directly, are you considering from an economic, financial, marketing standpoint of, do you have a dedicated factory for this stuff right now, or something more like a franchise scheme where it could be in any country? You could, something like a Shapeways kind of configuration where there's a central site for taking orders and constructing your shelf, but then you go out to local manufacturers who can simply produce and ship locally.
Mm-hmm. Yeah, sure. We actually use external manufacturers right now. We have 3 manufacturers, and they are all based in Poland. Because Poland actually, they have great wood manufacturers, also very well equipped, thanks to European Union. So that's a good spot to be. And but eventually, of course, that's the idea, that you could manufacture it locally. I mean, just from the economical standpoint, in terms of how much labor costs, at least for now, for the clients in Europe, it makes the most sense economically to keep manufacturing in Poland, but we can quite easily plug to different manufacturers if only they have the right machines. But for example, eventually we want to go to States with this, and then we would for sure manufacture either in States or in Canada. So it can be local manufacturing, but simultaneously we need to remember that those are a little bit more like lifestyle products, perhaps. So we need to basically just make sure that the quality is also kept. So we can add manufacturers, but it's but it takes. We basically need to make a couple of prototypes with every new manufacturer to make sure that they are doing everything right.
On a similar, will you be allowing designers to post designs and things like this, or is it too complicated?
We actually are working with designers. So we have a table. Oops, what is it? We have a table that was designed by our design advisor Yves Behar, and so that's the table, and here, and also the salt and pepper meal, that is like an entry-level product which you can also customize, but it's very modular. That was designed by Polish designer Christian Kowalski, but because the entire process of parametric design is still not, it's something that we also want to control, and we don't want to have also too many products. We don't want to become a marketplace. So rather, we think that we will work with designers, but they will be developing the design with us. Here you can see, you can change it to a hexagon, for example. Yeah, okay, but that's of course, an easier approach. All right, so thanks a lot.